we have talked about some introduction in lecture 1. In lecture 2, we have covered about microcontroller. In lecture 3, we have covered about ADC and DAC, basic interfacing, basics of interfacing. And lecture 5, we have talked about programmable peripheral interface. In lecture 6, that I will deliver on next Friday, and the topic is programmable interval timer. And today in lecture 7, I will give you one introductory lecture on embedded system. As because our course title is peripherals, interfacing and embedded systems. So before midterm, let's have some introductory idea about the embedded systems. So the lecture 6 will be delivered on next Friday, hopefully, inshallah. So this is how my plan before your midterm. Okay, so now today's topic is let's just start the recording. Today's topic is revelations towards embedded systems. Today I will show you that what facilities or what situations have directed us to develop or to run for embedded systems or to use embedded systems. And so what is an embedded system? I will not give you any formal definition. Rather, I'm showing you some devices. These all can be treated as embedded systems. But what we can categorize that among these embedded systems, likewise an automotive vehicle, some communication devices, or some very handy devices or gadgets we are using, those all can be categorized into different size embedded system. Even one aeroplane can be treated as an embedded system. So broadly, what we can do, broadly, these embedded systems can be categorized into two categories. One is large scale embedded systems, another is small scale embedded systems. And if we can categorize another way, that we can broadly categorize the embedded system into three broad categories. One is the devices we are using for our office systems and mobile as mobile equipment, and you can see the list of embedded devices. These all can be treated as embedded systems. I am not mentioning their names. The list is given there. Our typical structural building systems, those are also having the embedded devices nowadays. These are mostly very attractive devices, as because you are familiar with the term IoT, Internet of Things. So these all devices, the office equipment devices, are already being connected with the network, but we are trying to connect these systems, our office, our building systems, likewise our lighting system, generator system, air conditioning systems, CCTV, or IP camera systems, and those all are connected via internet nowadays, and we can control everything remotely. So this is a target area where most of the concentrations of embedded system developments are being done for the last few years. Another sector is the manufacturing and process control section, but here mostly robotic solutions or robots or robotic hand solutions performed they use the robotic solutions to conduct the manufacturing and process control, because in most of the factories or most of the manufacturing plants, what happens that human handheld works is being removed very early age of the, you can say that even in the manufacturing plant of some, uh, what we can say that even in the car plant, robotic hands are being used for the last few decades. So the we have some other very hazardous applications like nuclear power stations, energy control systems, where it is very much hazardous for the human beings to work there directly. So in that cases, embedded systems plays a vital role. And three other categories. One is transport, communications, and other equipment. You can see the transports already being, the names are given here. And in transport systems, it is also an example of embedded system. Communications, our GPS, our satellite communication, telephone, mobile communications. So everywhere we are using the embedded devices. And we have some other embedded equipment, likewise the ATM machines we are using, the credit card systems we are using, medical imaging equipment, uh, though VCRs we are not using nowadays, but uh, the list is made including those devices. Next, another example, that just to give you one idea about the automotive embedded systems. And nowadays, the automobile or the car or the vehicle we are using, uh, they may have hundreds of microprocessors. So this is just an statistics. Why do we need these hundred of microprocessors? Or you can consider microcontroller, because they do some target oriented task. Let's say that only 4-bit microcontroller checks the seat belt, and you know that if we don't connect the seat belt, it pop-ups or it gives some alarm signals. So how those are programmed? That is programmed by using some 4-bit microcontrollers, and microcontrollers runs the dashboard, so every information are visible to the drivers, or every information are visible to the users by using some microcontrollers everywhere in your automotive vehicle systems. And is another thing is that to control the engine status, or to know the engine status, the automotive vehicle's engine status, about 16 to 32-bit microprocessor is being used nowadays. So this is just an example. Even another example is that this is a model of BMW car, and where an ABS, anti-lock brake system, and automatic stability control uses the embedded systems. Now, the thing is that why embedded system is ruling the market? As because that it's tiny, it's small, and the small scale embedded devices are surrounded everywhere in our regular day life. And around 80 million PCs versus 3 billion embedded CPUs, central processing units or microcontrollers, you can say, that this is now running in the market. So in annually, if 80 million PCs are produced, in contrast, 3 billion embedded devices. And nowadays, according to Cisco, we have in 2020 we have around 50 billions of devices. Those are connected into the internet. So these all 50 billion devices can be treated as embedded devices. So you can consider that annually 3 billions of embedded CPUs are connected into the market. Now, now we'll go to the a bit more technical part. We have covered some introductory things about the embedded device. Embedding a computer means that in an embedded system, we have the same components. This is a typical block diagram. We have the same components where in every embedded system or embedded computer system, we have the central processing unit, we have the memory, input unit, and output unit. And most of the embedded devices, what it deals with the analog data, and after processing, it provides the analog output. So mostly, but in many cases nowadays, we are collecting the analog data, but after processing, digital output is our expectation. So why should we use microprocessors in embedded devices? Because microprocessors can simplify the design of families of products, and these are very often to use efficiently. Uh, and we have the already some platform is made for the microprocessors, so that is why it is easier, and you can consider this alternative solution of the microprocessor for target oriented tasks is the microcontrollers. And we have some instead of the for the pins or for the circuit design, we have some advanced technologies like FPGAs, some custom logics are there. These actually directed the microprocessor system to work for the embedded devices. And it's a typical embedded control system design from the designer's point of view, what a designer's or computer architects see. And of course, this is the designer's point of view, and later on I'll show you the customer's view. From designer's point of view, of course, we have the FPGA logic, we have the CPU, AD conversions, DA conversions. You know that already this sort of block diagram you are familiar with. And to run the system, of course, we need a software. We need a software platform. So this is the hardware part, and this is the software part. And inherently, to run the system, we have to depend on some external functions, likewise that electromechanical backup and safety, some external environment matters. We should have the diagnostic tools, human interface, and auxiliary systems like power cooling. So these are the major components. Those actually uh, needs are needful to design a, any embedded system. And these are the, you can say these are the components. We have some core components and we have some additional or external components. Those are required to design the embedded devices. Now, these much details are not seen by the, in recent days or in current age, this much of details are not visible to the users. What a user from customers or point of view, what actually they require. They need a solution, the attractive solution with reduced cost, with increased functionality, with improved performance, and with increased overall dependability. So, from users' point of view or from customers' point of view, they have their demand. But based on their demand or based on the market demand, the designers have to design the embedded control system. And here is the main development or typical development are being done for the last decade. And how these development or how these regulations are being made today, I will show you in my next slides. So this is nowadays you can consider that this is at the high end of the scale, that what a computer system currently having what a computer system is configured, how it is configured. So though it's a Intel Pentium 4, but from Intel Pentium 4 we have started using the 3.2 gigahertz frequency for the clock speed, and the power consumption is 103 watt. So this is at the high end of the scale. I'm talking about, say, let's say around 15 years ago, how we have started working with the embedded system or embedded devices. And if you compare at the low end of the scale, at that time we had the devices like this, where we were not dependent on the processor capacity, rather we were dependent on the communication, we are dependent on the transferring or exchanging our personal emotions or videos or files or photos. And here you can see that the power consumption, the main contribution was the power consumption. Whereas the computer system requires 103 watt, and the power consumption has been reduced almost uh, how many times? It's one fourth of a watt of 1 watt. So 250 to 300 of milliwatt. So most of the mass people, for the mass people interest, because PC was not the mass people interest at that time. At that time, the mass people interest was these sort of devices, and these sort of devices, huge revolutions have been made on these sort of devices, and you can see that nowadays we are having the version 12 of some of the devices, right? Or version 10, especially for Samsung or for iPhone, we are at the age of their version 12 or version 10 or 11. As because that they have started working on this sort of embedded devices around 15 years ago or around 20 years ago. Now another thing is that for this dramatic change, the computer technology, how the computer technology uh, is being changed, I'll show you now some statistics. So these are very general statistics. So let's see that how the processor speed is being doubled. So let's see two times, or the processor speed is doubled in every 1.5 years. For the last few decades, the processor speed from its revolution, or from its evolution, you can say that it has doubled for every 1.5 years. So the processor speed in terms of clock speed, and it is 100 times, the performance gain is 100, more than 100 times in the last decade. Next is the, in case of memory, the dynamic RAM capacity is doubled in every 2 years, and it is 64 times increased for the last decade. So this has a huge impact nowadays. Nowadays, even in a small tiny device, or in a smart system or smart computer system, or you can say in a smartphone, we are using a huge amount of memory and huge capacity of processor. Then the capacity of the disk is uh, it is more than two times in every year, and the cost per bit improves about 100% per year, and you can see that the size is increased 250 times. Now here is another thing about disk. I should talk about the cloud system, because most of the embedded devices are taking help of the cloud solution. So it makes our life more easier, that our data or users data can be stored into the cloud system. So here is another impact, or you can say that it has a huge uh, contribution towards the dramatic change of the computing system or computer technology. So actually, this is the last I'm talking about for around 10 years ago. The state of the art PC when you graduate, typically uh, clock speed, memory capacity, and disk capacity, these are almost like this. Processor speed is around 5 gigahertz, around or less than 5 gigahertz. Memory capacity is 8 gigabytes. But nowadays, 32 gigabytes are very simple or very general for the PCs. Disk capacity at least 2 terabytes. Okay, fine. So, but we are looking for some new uh, data unit. Just a minute. Just give me 1 minute. Okay. Sorry for the interruption. Okay. Now the new units we are looking for, that we are no longer talking about for the memory and for the speed or the disk capacity. We are no longer talking about the mega. Rather, we are in the age of giga or tera. And you see the new data units, uh, tera, peta, exa, zeta, iota, and these time is not that much far that we are going to use these new units like peta, exa, zeta, and iota. So though we have started using tera already, and most probably kilo, mega will be some incorrect terminologies in near future. So this is another, just you can visualize that this picture is viral in everywhere in social media. This then 15 megabyte hard disk drive, how it is being shifted by IBM in 1956. And you can see that the claim that we have made here, and you can now compute that how in every 2 years is being doubled. Okay. Next, another example of computer revolution is that at the left side, we have an IBM PC that was manufactured in 1981, and we have a Mica's mode. We say it's a sensor mode that was marketed in 2005, and the Mica's mode was first designed by UC Berkeley and University of California, Berkeley. They have invented this Mica's mode, and later on it was widely used for wireless sensor networks in for many applications, for many hazardous applications. Now, you see here I have given one comparison about the computing system and the Mica's modes. It's a tiny device and it's a huge device. You can visualize. You see that the clock speed, or the speed it has, 4.77 megahertz. So you can consider that it has used 8086 microprocessor. So almost 5 megahertz is the clock speed. And the Micas we have, that has a clock speed of 4 megahertz. The RAM size is around 16 to 56 kilobyte of RAM it has used, whereas this tiny device has 128 kilobyte of RAM. At that time, we didn't have the flash drive, a flash memory, but we had the floppies, very small floppy devices, and that has a maximum size of 144 kilobyte actually, or 144 megabyte later on we have seen, but 160 kilobyte of floppy size. Whereas nowadays, this device, this device has 512 kilobyte of flash. Nowadays, more flash memory can be incorporated with this. So I'm talking about 2005. The power consumption, it requires 64 watt, whereas it requires only 14 milliwatt, and you can see the dimensions. Dimensions in a sense that weight, height, and uh, you see the weight. Weight is the 25 pounds. I see only zero point 0.5 ounce. Zero point 0.5 ounce is the weight, very lightly loaded or lightweight of for these micas, and the dimension is height, width, and length. So the you see is very small, only in inch. So you can have an idea that the device we have used in 80s and what device we are using in 2005. Another revolution is the wireless revolutions. This is just an just an you can say this is just a comparative scenario that uh, earlier days the Boston Central Telephone Station after one blizzard in 1881 it was totally surrounded by the wires, different sorts of wires because most of the connectivity wires connects to a single point. But the wireless revolution has made our life easier. Nowadays, we can avoid in our daily life system, we can avoid the wires. So this also has a huge impact uh, for the revolution towards embedded devices. Now, so what challenges we are facing for the embedded devices? Most of the devices are mobile, so this is one challenge. So though it makes users life very easy, but from the uh, embedded designer's point of view, it's very complex because for every solution, for the communication, for the data transmission, so every time we need to consider the mobility of the users, and another is the massive IO interfacing. The massive IO interfacing through wirelessly because we are no longer connected with the wired computer system. So these two are the main challenge considering the mobility, considering the IO interfacing. So mobility in most of the wireless communication protocols, we have to consider these mobility issues. But as our title, our course is related with the IO interfacing. So here is our mobility. Mobility should be considered for IO interfacing, and the what technique makes our life easier? One is the Bluetooth technique. The Bluetooth is the wireless technology for IO interfacing, though it has a very limited uh, range, maybe maximum practically it is less than 50 meters, but theoretically it is uh, around 100 meters or 80 to 100 meters. So Bluetooth technology is a massive contributor for IO interfacing for these embedded devices. So that is why I have included one another statistics is that the energy issue that one another issue considering the mobile devices. Most of the devices are battery operated. You have seen that that direct current or direct power source are not connected to these devices. So that is why typically is the power consumption issue, and for that reason we mostly we use the battery for these devices, and we have to prolong the battery lifetime. So this is another challenge, and you can see that which component takes more power in compared to uh, other. So let's see the communication. For the communication, mostly communication requires more power. So large cost of communications related to the computation. So you can see that for each and every bit transmission through Bluetooth technology, 150 nanojoule per bit, these amounts of energy is required. In 2004, for the typical devices, this is another statistics that around 5 nanojoule per bit. So there is some improvement. There is some improvement in between. Another technology is another point is that 1.5 milliwatt, and whereas the power consumption is 50 microwatt. So in that sense, one improvement has made around from 1999 to 2004, and nowadays the technology is being more advanced and uh, more efficient, you can say. But computation for computation case, around 190 millions of operations per second can be done in these sort of embedded devices. And for each of these operations, we need 5 picojoule of energy. So here the consideration is made based on some data rate of 10 kilobit per second using radio, wireless radio, and the range is 10-meter range. Within 10-meter range, based on this statistics is made. But what is the bottom line? The bottom line is the large cost of communication related to computation continues. So whenever any embedded system or embedded protocol is being designed, the designers always kept in mind that communication requires more power in compared to computation. So the bottom line is so far whatever we have learned is that the computer system, and nowadays the new term is the embedded system. By computer system, nowadays we often mean that the general purpose digital computers that interact with humans and possibly with each other. But change in trend using embedded systems, it is specifically for target-oriented tasks, and you can consider these are special purpose computers, so that can do the target-oriented task. And mostly unattended scenario, likewise in automatic scenarios, without humans, we can use the embedded systems. And also more environments where computing is not explicitly possible, that can be included by using our embedded devices. So here is another you can say another comparison. Computer system is more interactive. That means human computer interaction is required for to run the computer system. But these are reactive. We say event driven. That means it is situation dependent. Embedded systems or embedded devices are situation dependent. So in that sense, we can say these are event driven. And this computer system where discrete time is not counted, rather continuously we can work with this. But in this case, timeliness is important and very critical, because mostly these are automatic. And as human touch is not there, so the timeliness is very important and very critical. We can say this is a standalone system, or it can be networked. A computer can be networked, but it is not automatic. It is human controlled. But in this sort of system, computing component may be controlled by the external system or automatically. So this is another main difference between computer system and embedded system. And finally, it works in an isolated environment, but we say embedded devices work in alien environment where people may or human being may not attend that place. So it's mostly for alien environment. So lastly, I'm almost at the end of today's class. Lastly, the implications of being embedded, what advantages we are having by using the embedded systems. First of all, low cost hardware. We are having the low cost hardware. Our embedded system devices are very cheap. You can consider in compared to the earlier day devices, or nowadays the computing system we are using, that is much more expensive. The second one is very limited storage space. Using very limited storage space, we can do very aggressive tasks. And development of environment is different from execution environment. We can consider a varieties of heterogeneous environment in our regular day life for computing the different sorts of data. Long and uninterrupted running times. Most of the embedded systems are running 24/7. So we are, as they are automatic, as they are event driven, using event driven systems. So no longer human is controlling those. So in that sense, these are those embedded devices having long running times. And already I have talked about the alien environments. Harsh and human unattended scenario can be covered by the embedded devices, and it increase the reliability constraints as well. And finally, the timeliness expectations, the time complexity, that means any real-time scenario can be captured by the embedded system. So these are some implications you can consider. So I have shown you 5 implications, and that's it for today. And actually, in these lectures, so this is a lecture that how we are being guided, for what technology have guided us to design the embedded system. Today I have shown you. This is a brief introduction before your midterm exam on embedded system. And hopefully after the midterm, we will talk about some embedded protocol. I will specifically talk about 2 uh, embedded communication protocol. One is CAN, Control Area Network, another is Inter-IC Bus System. So hopefully after midterm, we will complete those 2 protocols. So that's it for today. Do you have any questions? So how many students? Almost 23 students have joined. So another thing is that are you facing any problem in using the Proteus software due to its CAC version? Have you faced any problem to save your projects? Some of the students have make a phone call to me that they can't save the project file using the save as options of the Proteus. So
yes, sir, some of us face that.
Okay, so you can check it. You can check it, and let's see that whether any other version is available online or not for Proteus. Uh, Please you yourself check that whether you can download any other version of Proteus or not. Or I will try. I will also try. If it that is available, then I will collect and I will also make the distribution towards you. So thank you, and hopefully
there are some problems with the lab task, মানে স্যার যেটা হয়েছে সেটা হলো
the video is not available, right?
স্যার ওইটা তো একটা প্রবলেম আছে। এমনি ভিডিওটা আমি আগেই দেখে ফেলছিলাম, কিন্তু মানে যেটা হয় ওই ভিডিওতে যেটা করে সেটা আসলে মানে আসে না। মানে ভিডিওতে দেখায় যে একটা একটা করে জ্বলতেছে আর কি, কিন্তু ওইটা আসলে মানে ওই কোডে আসে না, মানে সব একসাথে জ্বলে অলওয়েজ জ্বলতে থাকে আর কি। ওইটা সবারই হচ্ছে স্যার, মানে ভিডিওর
Okay,
সাথে।
this problem, এটা তো code problem. So we can identify that. We can identify that by analyzing another code. সেটা আমরা পরে দেখছি। But the main problemটা হচ্ছে যে crack version কাজ করতেছে না বা save as করা যাচ্ছে না। এটা একটা মেইন প্রবলেম। আর একটা হচ্ছে ভিডিওটা ওরা সরাই ফেলছে, যে যারা যে ব্লগ থেকে আমি ভিডিওটা দিয়েছিলাম সেই ব্লগ থেকে ভিডিওটা তারা সরিয়ে ফেলছে। So I'll check that. I mean, already I have given another video tutorial, video link to the section 2B. Uh, that video tutorial also includes 4 LEDs and 4 LEDs. So let's see if that is not workable, you can follow the other video tutorial. So I will upload or I will update the lab material, then I will notify you, inshallah.
স্যার একটু ডেডলাইনটা বাড়ায় দিন স্যার।
Okay. Okay. If I make this sort of change, then I'll extend the deadline, inshallah.
থ্যাংক ইউ স্যার।
So thank you, and see you on next Tuesday, next Friday with lecture 6. Actually, today we have completed lecture 7. Up to lecture 7, your midterm syllabus will be covered, and hopefully on lecture 6, I will deliver the lecture on next Friday. So thank you.
Assalamu alaikum, sir.